change of state. You see, whenever the heat is supplied to a substance, substance could utilize that heat in two ways. One, in raising its temperature, the other in changing its state. When temperature is raised, obviously the heat that is absorbed is used in increasing the distance between the molecules and expansion takes place. But when state changes, it simply means that the whole process is going to take place at constant temperature, because in that very process the heat absorbed is not going to increase the distance. It will break the bond, it will utilize in breaking the bond. So, at the same temperature, heat will be absorbed for breaking the bond of the substance concerned. This amount of heat per unit mass absorbed is known as latent heat. The formula that we adopt or we use is M into L. L is latent heat. When it is from solid to liquid, you call it melting, and if it is liquid to gas, you call it vaporization, or also boiling. You see, in these two states, in these two processes, always the heat will be required that will be known as latent heat. If we consider the process of melting, it's going to be known as latent heat of melting. Old classical term for melting was fusion, but now it is discarded because fusion refers to something very gigantic type of process that we study in nuclear physics. So now most favorable term, preferable term is only melting. If it is boiling, then we call it latent heat of vaporization. You see, if we consider the state of water, solid, liquid, gas, that is ice, water and steam, then ice to water, latent heat of melting, this is 80 calorie per gram, and water to steam, latent heat of vaporization, this is 540 calorie per gram. Remember, the reverse is equally true. If the water gets converted into ice, the process would be known as freezing. This is also obviously change of state. When steam gets converted into water, this is condensation, and again this is the process of change of state. In both the cases, either it is left to right or right to left, in both the cases its value is going to be same, here 80 and here it's going to be 540. One very good question arises that why ice at 0 degrees Celsius appears more colder than water at 0 degrees Celsius? Because ice at 0 degrees Celsius, it's a melting point of ice. Right now, it is ready to change in water. Only the requirement is that of 80 calorie by 1 gram. So soon as you touch the ice at 0 degrees Celsius, it will immediately start melting. That means it will immediately start absorbing at the rate of 80 calorie per gram. Whereas water is in a position only to get increased or get heated. So it will increase simply by 1 degree, it will require 1 calorie, then again, and so on. It is a slower process. So heat absorbed from your body is greater when you touch the ice, and likewise 100 degrees Celsius water and 100 degrees Celsius steam. Steam will be more dangerous for you because it will liberate more amount of heat, 540 calorie. Steam will liberate immediately 540 calorie to your body, and your body might burn.